I'm appropriate greetings, everyone. Today we're going to be covering installing new apps and runtimes on Into the Terminal. So let's jump right on in. So Nate, we're installing new apps and runtimes, but I guess we have to install some apps and runtimes to start off with, right?
But Scott, RHEL doesn't run new apps and runtimes, right? Isn't that isn't that the problem with RHEL? Everything's old. Everything's old in RHEL.
I mean, it is my grandfather's Linux,
Right.
and so I have my 20-year-old Python on there. Not really,
Right.
right? So I
Today we're
just
going to try to
installed
dispel that myth, huh?
Python. Here's hoping. So the version of Python 3 that comes with RHEL 9 is Python 3.9. But we do periodically release updated languages and runtimes for your version of RHEL. We started this back in RHEL 7 because it became apparent that keeping something or having a language set that was the only language set available for 10 years was not great for a lot of folks. So we started to publish kind of intermediate updates that allow you to choose what version of different things you would like. So here we have Python 3.9, which is the default version of Python 3. But if we do a DNF list, we can see that Python 3.11 is also available. And so the concept that we use for distributing new applications and runtimes, we call that term application streams. But an application stream can be a variety of delivery mechanisms to your machine. So Nate, for Python 3.11, what do we need to do to get it on this box?
So you'd have to do a DNF install on Python 3.11. That's the package names right there. And of course, there's a bunch of sub packages or dependency packages for different pieces of Python, and that's just how RPM works on RHEL. But to get the core right there, 3.11.
Yeah, and what ends up happening during the installation is if we look at the user bin directory, oops, try that again with less craziness.
There we go.
Um, yeah, so you can see that we have both versions installed at the same time, right? So Python 3.9, which is the default that comes with RHEL 8, and then we just installed that Python 3.11, and because they're stored in different subdirectories, we're able to keep the files between them completely separate. But that means that if you want to use Python 3.11, you actually have to refer to it in your shebang in your Python script,
Right.
right? So you'd shebang user bin Python 3.11. If you just did Python 3, you'd end up with Python 3.9 because you just said user bin Python 3, it points to Python 3.9, right?
But can't I just change that symlink, Scott? I really want to use Python 3.11.
So you could. I mean, you are capable of doing that as the administrator of the machine. However, I would recommend against it because we do all of our application testing for the stuff that we ship with RHEL, like all the administrative applications and stuff, using the system Python, which is Python 3.9. So you can change that symbolic link to 3.11, but now you're running things that we don't always test all the iterations of because we assume that system Python points to 3.9 on this box.
Right. You may have noticed that Python is pretty heavily used in most utilities in Linux, not just RHEL, lots of other distributions as well.
Right. So here we're showing an application stream implemented as RPMs that could be installed side by side. But
Right.
that's not the case for all of our application streams. So we just added a new um, application to our stack in 9.10. Sorry, 9.2. Nate, you want to tell us about our new thing that we just added?
Who remembers Tomcat? We had Tomcat, went away in I guess 9, right? We had it in 8, went away in 9.
We had it in 7. It went away in
Was it not
8.
in 8?
And
I
yeah,
lost track.
and then it has come back in 9.2. So because we added it back as an RPM, And then subsequent versions that we may make available could either be an RPM if they can be installed in parallel, like we saw with Python, or they may be installed as a module or offered as a module. And we have some of those to show you too. But right, so here, if we look at just what's available for Tomcat, there's Tomcat 9062.
All right. And now what we may see, right, is if a new version of Tomcat comes to RHEL, it may be implemented similar to how it was implemented with Python there, where we had the dash and then the version number, or it could come as a different type, which is kind of what we're
Yeah,
going to talk about very soon.
so I actually think that if it were to be updated, and we'll see, because now we're talking about future things, right? So I can't know the
Right.
future things.
Right.
But I think if we were going to apply updates and make updates for Tomcat available, we would do it in a similar fashion that we're doing it today for Nginx.
Right.
So Nginx from RHEL 9 is version 1.20, and it comes as an RPM. But with 9.2, we actually shipped a updated release of Nginx as well. And Nate, how can we see that updated version of Nginx?
So this is, and maybe we'll go into the details as to why this is the way it is when we get into the main section of the show. But suffice to say, at the moment, we'll just say it's a module. It's implemented as a module, and this is so you could install either of them, right? You can put in 1.22, which is in the modules, or 1.2, which is in the core RPM repositories.
Right. And so a module is a new version of a thing. However, modules are implemented so that you can only have one installed at any given time.
Right.
So if we were to install this Nginx 1.22, first off, we have to tell it that we want to work with this new module, misspell module. And we can only have one version of Nginx installed at a given time because if we actually looked at how the module was built, it would replace things like user bin Nginx, which was provided by our previous RPM. And so
Right.
modules are designed so that only one can exist on the machine at a time, but you can swap them out for newer or older versions as you see fit. Right, so we're able to upgrade this machine to 1.22, but you can see that that's installed as a module. And now that we're on a modular packaging of Nginx, if in sometime in the future, maybe we release Nginx 1.24. So for that, we'd have to remove 1.22 and then add back onto the system 1.24. So
Right.
modules also don't have the best upgradability. The actual blessed process is remove the module and put back the new version of the module that you want to replace it with.
Right.
But
Now
that
this
also allows
doesn't
you to go up or down in version.
Right. Now, this doesn't mean that Nginx 1.2 is dead in RHEL because there's a module for 2.2 for 1.22. It means that they will, in parallel, continue forward, right? Backports and patches will still come to 2.0, right, or 1.20, right? And the modular version will also continue to receive updates. And once 2.4 or whatever the next thing is comes out, that will also continue in its own little path, right? Now, there's different support policies for each of those, but those are outlined in our life cycles page.
Yep. So I think that runs us off our list of what we're covering in the critical path today, and we'll go a little bit deeper after the transition. So stay with us. We're also going to talk about Flatpaks after the transition, which is
Yay.
another thing that we're delivering through application streams, right? Which is a way of getting newer software on top of RHEL. Hey, everybody. Thanks for staying
Well, that
with
was fun.
the
Fun
transition.
packagey stuff.
Smash
Yeah.
that like and subscribe button so that we can keep producing more content like this. This is the part of the show where we interact with our audience. If you are not viewing this live and you would like to interact with us, we also do a lot of combing of the comments. So if there's ever a question you're watching deferred and you would like to interact with us, please put a comment on and we'll get to it.
Yeah,
So
we
Nate,
love the interaction.
um, so you wanted to do a little bit more on um, just kind of inspection on packages and modules, right?
Yeah, so it comes to mind that a lot of people compare what we're doing with modules and app streams to what we used to do with software collections, right? There's nuance there, right? They're not quite the same thing in every situation. Um, I don't know if we wanted to talk a little more about that, right? So the installation of Python, the example earlier, is more similar to the old software collections, right? The modules is kind of a different thing.
Yeah, and that's because for software collections, in fact, Python is still considered a software collection because you can have multiple versions installed at the same time. There's a lot of challenges in tracking all those multiple versions, right? Like
Right.
how many Postgreses do you need installed on a box? And you can't
Right.
have them all running at the same time unless you do a bunch of other things like change the ports that they're attaching to. And like there's a whole bunch of considerations that one has to have for running multiple versions of the same application at the same time. And I think a cleaner implementation of that would be containers. Like if you want to have multiple
Right.
Postgreses, like cool, make a Postgres container for each version. Then you can, as part of your container spin up, attach them whatever ports they need to attach to. Um, and I
All
see
right.
Eric is interrupting us with a question. What is the RHEL way of installing multiple versions of the same software? Update alternative syntax always confuses me. And that's from Shantanu.
Right. So there's I mean, a lot of this depends on the package, right? So things like Python isn't managed by alternatives, which is the thing that we were talking about before the show, Scott. But things like Java still are, right?
Yeah, and so Python not being managed by alternatives is actually a change in RHEL 9. So RHEL 8 alternatives managed Python because we shipped both Python 2 and 3, which was a big change. And I think the same is true for RHEL 7. Um, but if we just do a alternatives list here, just list. Oh, in this dash dash list. These are the things that are managed by the alternative subsystem. So if you have a situation where you have multiple things installed at the same time, and I saw that Imran asked about Java, and you can see that Java is one of these managed alternatives. So you can have them both installed at the same time, which puts them both in their different directory structures. But if somebody uses user bin Java, you want that to go to one or the other. And that's what alternatives controls. So alternatives allows you to set kind of a system setting that if somebody just references Java or Python 3 or IP tables, this is the actual executable that backs that call. And so that allows you to kind of have these multiple directories of separate content, but still route kind of general system use to a specific version that you want on the machine. You can always reference the specific version you want by using its full path name to get to its directory structure or executable in your references to it.
So Shantanu goes on to ask, say, well, I guess continue the question, not necessarily databases, but things like compiler tool chains and whatnot. That, I guess, some of that is controlled by alternatives. Some of it you can control by setting your environment. I don't know if we have a tool specifically to switch that's built into RHEL, but there's lots of ways to get that done in Linux, but it may be a little deeper than we were planning on going today.
Yeah. So a lot of things for like an example would be building RPMs. Happens to be top of my mind because I'm talking about it at Red Hat Summit this year. But there's macro definitions that are defined in the RPM building environment that indicate, hey, when I say make, or I say GCC, this is the thing I'm talking about. And it's actually a token that you put into your configuration that it looks up later on to figure out like where the actual executable to back that macro is set to. Nate, you referenced environment variables. So the Java home variable is one that I used to use a lot in the JBoss world, where as a person, I can say, this is the Java I want. So even though there might be multiples on the system, I can set the Java home variable in my environment to say, this is the one I am working with. And that's a way to manage it. Python uses virtual environments, right? The venv. That's a way that you can manage this. So there's a bunch of different mechanisms that one can choose to determine which backing application is really being used by the developer or the application stack.
Yeah, there was a brief time where I spent working in higher ed in HPC, and on an HPC cluster, right? You've got a control node where you submit jobs and whatnot, and generally you can't just lock in on a certain version of Python, for example, or a version of a compiler or a version of any language, because jobs might require different versions to run the way that they're expected to run. And there's a whole ecosystem around how to easily switch those for a job, right? So this goes deep if you really want it to.
All right. So do you want to talk about Flatpaks, Nate?
Yeah, it seems like we've gone a bit astray here, but that's fine. Let's touch on Flatpaks because that's a relatively new feature in RHEL 9, right? That came with 9.0, or was it 9.1?
So we started it in 8,
Okay,
but there were some significant changes to how we managed Flatpaks that were subsequent with 9. So in 8, we shipped Flatpak, and our list of applications was small, and we described it as we're thinking about including Flatpak with RHEL. And in RHEL 9, we actually did a lot better with that, because one of the things with Flatpak is they're user installable. And so, how
right.
do we make sure that if a CVE is issued, as an example, and we have updated that application, that users know that they need to install it, right? And so, one of the things that we did between 8 and 9 is actually build out some of that infrastructure to say, hey, when we're making changes in how we're building RPMs and containers, because they also get updated by Red Hat for things like UBI, then we also need to make sure that we're updating these flatpaks that we're building too. And so all that was kind of plumbed and put together between 8 and 9, which is why we have a better catalog of flatpaks for 9. So do we want to go back into the terminal and like monkey around with flatpaks a little bit?
Yeah, let's put Discord on our server, right? Because that's what I use Flatpaks for on Linux usually.
Hmm. But is Discord software that is distributed by Red Hat?
Probably not.
No, it is not. But we do distribute things like LibreOffice, Firefox, Thunderbird, and you'll notice that at least for the Flatpaks that are shipped by Red Hat, they are graphical applications, right? Because they're meant to be user installable by people using a graphical workstation.
Right.
So when we install Flatpak, you'll notice that as part of its dependencies, it slurps in a whole bunch of X Windows stuff. So Eric, we now have server with a GUI. Just saying.
You guys can't
You
see,
guys
but he's
get-
shaking his head from behind the glass.
All right. So now that we've installed Flatpak, the executable and all of its dependencies, we can become a regular user. I have this user named RHEL, just a normal everyday user,
It's a very creative
and
name.
we can. I know. This is why we're in the RHEL BU, Nate, because we get to name stuff.
Right. Right. Very creatively.
So as a user, you need to add your Flatpak repositories. And so this
Right.
Flatpak remote add allows me to define a repository.
And this is really just like a software repository in Yum if you were to try to equate the two, except you're getting these sort of containerized applications instead, which I guess brings the question, right? Are these really containers? They are, aren't they? But they're not like
Um,
Podman containers, are they?
no. So let's change the term container a little bit because it's one of those terms that gets overloaded, I think.
Right.
Um, so what this is an archive of files. And a container, like a application container, Podman container, that's really what that is too, right? It's a file system image that has a bunch of stuff placed into it that you
Right.
can then port around where you need it. And Flatpak is kind of the same thing. It's a archive of content that gets shipped places and then you unpackage it and then you can use what's in there. But it's all self-contained so that you can make sure that between two different systems, they're getting the exact identical set of files if they're installing the same Flatpak. All right, so here we've installed Flatpak. We've defined our repository. It's called a RHEL-repo. Again, this is why we name things. And one weird thing about Red Hat's Flatpak repo is it sits behind our CDN, which means that if users are going to use it, they need to log into the CDN so that they can be authorized to download content from Red Hat's servers. So we can use Podman to do that. And this is temporary. There's a whole bunch of steps that I'm not going to go through on how you could permanently add this.
Super secret password.
Yeah. And now that I've logged into the CDN, I can start interacting with this Flatpak repository that lives in the Red Hat systems. So we could do something like a Flatpak search for an application. One thing I've noticed is the Flatpak likes to be authenticated with a lot. I don't know why.
I wonder if you're actually in an X GUI, if some of that is handed off to the authentication mechanisms that
Oh,
are
to like
in GNOME.
Bus or something. Could
Yeah.
be. So here's the Flatpak that's available for Firefox. So if we want to install it, I have to tell it where to install it from because if you have multiple different Flatpak repositories configured, they might be offering similarly named applications. So when you do your install, you actually tell it exactly which repository you want to pull this application from. And then we want to make sure that people are authenticated before they install something on the machine.
Hmm.
So Rando didn't just walk up to their unlocked keyboard and do stuff.
And the other neat
And it's going
thing I've noticed about Flatpak is if you have more than one repository and the package exists in more than one, it'll give you a nice little select list that you can just pick which repo you wanted to install it from, instead of the confusion that could come from like an RPM repo that has conflicting package names, right? It's really handy.
yeah, or versions for that matter.
Right, right,
So it'll take a little bit because we're like downloading and installing stuff. So let me
right.
take a quick the chat here. So Shantanu asks, how does Red Hat prioritize or decide what tech should be gotten behind, like Flatpak or Snap or AppImage, etc.? Um, it's a mix. So sometimes Red Hat leads that, right? Where we have developers that are like, hey, this is the thing I'm working on. Um, and that's how the decision gets made to add it to Fedora or add it as a tech preview to RHEL. Sometimes it's us looking at other distributions and other Linux community stuff and saying, hey, that's a really good idea, and we should include that in RHEL as well. And that's kind of what happened with Flatpak. We were looking at other distributions, and they were implementing software management this way to ease a problem of having regular people be able to install graphical software without needing their administrator or without needing root authority on the system. Plus, there's the mechanism of like making sure we know what someone has downloaded and installed, right? We know what version was there, how it was maintained, that kind of thing. So that's how we got started with Flatpak.
And then, of course, there's customer requests, right? If enough customers say we want a thing, then we hear that, you know? I don't know that there were a lot of customers banging down the door for Flatpak. Maybe there were, but there's a lot of features that come to RHEL that are exactly that, requests from customers. There's this thing that we need, or this thing we need for compliance or whatever, and we'll look into it and bring it into RHEL.
Yeah, and it turns out that Flatpak is used in other things too. Like we were looking for a while at what how Linuxes were being built for automotive, and a lot of them were using a build called Yocto, and Yocto also uses Flatpak for installing software on top of it, right? So, our engineering department, our um, technology office, we're looking around at things and different stuff that other people are doing to see if that's something that we're interested in doing too, or solves problems that our customers have as well. All right, so we can see that our Flatpak is here and it's installed. So now I can do a Flatpak run. But instead of using the name, I have to use this app ID. That's the syntax requirements of Flatpak. And because this machine is not a graphical system, no one is surprised to see that no display environment variable has been specified. It doesn't actually run because it's not able to connect to my graphical environment.
Can't you just start X and then get into a GUI? Come on.
Maybe. Not through this SSH session. I guess if I had SSH'd with X window tunneling, that might have worked.
There you go.
But yeah. But I wanted to show the full thing of like installing, and then this is how you would execute it on the command line.
Right. All right. So yeah, Flatpak, all the things.
All right.
I have seen things where Flatpak is used for command liney stuff. Like, I don't know. I think I've seen like Let's Encrypt bot in a Flatpak so that you don't have to install certbot and stuff on your machine. Again, these aren't things that are provided through your Red Hat repository, but there's other use cases for this other than just I need to run this little GUI thing. So just for folks' education there.
Yeah. And I think the bigger thing is that when we talk about application streams, a couple of years ago when we introduced the concept, we were talking mostly about modularly shipped content. So people kind of associated application stream with modules. But that's not really the case. It could be what we traditionally called software collections, like we saw with Python today. It could be individual RPMs, like we saw with Tomcat. Or it could be things like Flatpaks. So application streams, if you see that in documentation from Red Hat, is really talking about getting newer applications and runtimes in people's hands. And that
So
could
application streams, you might say, is more like the concept of being able to get newer things than the mechanism in which you're getting them.
Correct. The implementation might be RPMs, modular RPMs, Flatpaks, other stuff. But we want to make sure that people have options so that when they employ this RHEL for, 10 years, they don't have to make the choice on day one of what they're going to be using 10 years from now on that machine. Right? That they can actually like make adjustments and make changes over the lifespan of that system and the applications that run on top of that system that are interesting and beneficial to the organization that's running that system.
Right. Because you need to be realistic. The stuff that was included in RHEL on day one, while we would like to think will last 10 years, sometimes it doesn't. Development, applications, and whatnot, they have requirements that change over time, and we have to keep up with them. And that's exactly what AppStreams is here to do.
Yeah. And so for things like Python, I think we're really good at that. Like 3.9 is going to be the Python that will be around in many years from now on RHEL 9. But stuff like Go, Rust, LLVM, Nginx, where the community itself moves at a much more rapid pace, we're not going to be able to take something that the community itself has abandoned and just keep maintaining it forever. And so that's why you'll see, if you look at the application streams lifecycle page, there's actually like different times on how long the support will be good for some of those versions of app streams. And that's mostly because of how the community that manages that open source software has chosen to run their life cycles, so that we're well aligned with it, and don't have to kind of do a lot more effort to maintain this older thing that no one else seems to care about maintaining.
Yeah. Yeah, this was a really big problem, at least for me as an administrator back in the RHEL, I think it was 7 days, because of PHP. Our web team needed a newer version of PHP, and it just wasn't available on RHEL, even in SCL. SCL wasn't even new enough for what they were trying to do. So it really turned into a big pain in the butt. So I'm glad that that's changed now.
So Nate, next time your developer comes to you and says, "Hey, I need the latest Python, PHP, Node.js," what are you going to say?
Go look in app streams.
Or like, "Hey, let me check." Clackety, clackety, clack.
Yeah,
Oh yeah,
right.
no problem.
Yep.
We're good.
We got it. It's done. Sorry, I was trying to come up with something snarky and I couldn't.
So we are not going to be doing Into the Terminal next week because we will be at Red Hat Summit. If you're going to be in Boston, please swing by the Red Hat booth. I'm sure myself, Eric, Nate, Mr. Matthew Yee will all be in attendance, plus your favorite product managers from RHEL. We will also be doing a couple of live streams as part of that. So if you're not attending Summit, you can join us in the morning or in the afternoon to hear some of what's going on. And I may even also have, don't tell Eric, I may also have some activities that people can do interactively that we're also deploying at Summit, but they're not there. So remote activities, pay attention next week. We'll roll them out. Nate, any final words before we bid adieu to our guests?
No, this has been great. I mean, everybody put your new applications on RHEL. Don't believe the hype. You can run new stuff on RHEL.
Fair enough. All right, everyone. Until next time, thanks for joining us for Into the Terminal.
Have a good one, everybody.